Hello, Algebra 2. Today we're going to look at factoring polynomials completely. So in the last lesson you learned some factoring tools, and I think we also have some from back when we were studying parabolas more in depth. So let's go ahead and try to answer these questions. So my class today worked on these first two problems as a warm-up. So let's see if we can answer them. So I'd pause the video now if you're continuing from a previous lesson or if you missed class. So it says, is the line x minus 5 a factor of this parabola? The second question, pretty similar, is this line x plus 2 a factor of this quartic tetranomial? So I think we have a variety of tools at our disposal. The most obvious new tool that we learned was synthetic division. So I'm going to use synthetic division and see if I get a remainder or not. If I get a remainder, then it will not go in evenly, so it won't be a factor. If I do get a 0 as my remainder, in other words, don't have a remainder, it will factor in evenly and be a factor. Okay, so here we go. So I want to put in the 0 that corresponds to the factor, which is 5, or the opposite of x minus 5. And I want to pull off the coefficients of my thing I'm dividing into, like so. Of course, synthetic division always goes plus. So here we go. Drop 3, multiply, add, multiply. That's a little bit challenging. 5 times 10 is 50. 5 times 7 is 35. That's 85. And add, and you get 76, right? Okay, so my remainder is, in fact, that last term. So let me put my remainder box in my synthetic division. So that says that basically the answer is no. Make sure your thoughts are complete. No doesn't really describe anything well. It's not a complete answer, and I wouldn't accept it. So no, x minus 5 is not a factor of, and you could just go ahead and write down your parabola, or you could just say something like of this parabola. Okay, let's do the same thing and check if x plus 2 is a factor of this quartic. So here we go. I'm going to test the 0 that corresponds to the factor, that's negative 2. Pull off my coefficients, 3, 6. Watch out here, x squared needs to have its place value held. Don't skip it, put a 0. And then I'm going to do synthetic division. So I'll bring down the 3, multiply, and add. Multiply, and add. Multiply, multiply that, you get 0, and add. Multiply, and add. So our last number is the remainder. Since this remainder was nothing, I think that this guy is indeed a factor, so let's write out our answer correctly. So yes, comma, the line x plus 2 is a factor of this quartic tetranomial. Like so. So there's the way you can answer simple questions like that. Now we're going to use those types of tools to investigate and factor much more complex polynomials. Because as I described in my class, it's kind of like these candidate factors, these things we thought might be factors, these guys, they came out of nowhere. In my class I referred to it as they came from the textbook no. It's kind of like they were shoved in your face and there's no idea where they came from. So there's a variety of ways to come up with things to test. We've got the tool, or one of the tools, synthetic division, to use as our testing device. So how do we come up with guys to test and see if they're in fact zeros leading to factors in the first place? One of the great tools in the modern era is to use your graphing calculator. So let's use our graphing calculator and start to factor polynomials completely. So let me get this out of the way. Let's look at a couple polynomials that we can factor completely. Let's start with this one. So number 3. Let's say we have f of x equals 2x cubed plus x squared plus 8x plus 4. Let's use our calculator to get ourselves started here. So what will be a good 0 to test with synthetic division? Put it in your calculator. Graph it. Got something in there, clear it. Time to graph. I'm going to zoom standard and have a look at my basic polynomial shape. Now, it shouldn't surprise you that you have this kind of shape because it's a cubic polynomial, and we've investigated a few graphs of those kinds of things already. Maybe I can't see more of the zeros, so I might need to zoom out. Let's just check with a rough zoom out. See if I can see any more zeros besides that one. I can't. It's of course possible, they're just farther out, but let's just start with that one and see what happens. So I'm going to zoom back in, or zoom back to standard, I should say, and start with that one. So what is this one? Let's compute it. Second calculate, second trace, and 0. So I'm going to go on the left-hand side, I'm going to go on the right-hand side, and I'm going to guess. Okay, it looks like -1/2 is what that 0 is. That gives us a good place to start. So we're going to say, all right, synthetic division time. -1/2 is supposed to be a 0. Let's do it and check that first. So 2, 1, 8, and 4. So if I bring the 2 down, I'll get 2. 2 times -1/2 is -1. Those add up to 0. That times that is 0. 8 plus 0 is 8. -1/2 of 8, or 8 divided by 2, is 4, and negative. So if we add those up, we get 0. I was expecting that all along. So you might be asking, why did I do it then? Well, I wanted to be extra sure that in fact -2 was a 0. I also want this stuff. So what is this stuff? Well, it's the key to the rest of our problem. I can't see any more zeros on my calculator picture, but I think there are more. In fact, the fundamental theorem of algebra, which we'll write down formally later this week, says if you have a third-degree polynomial, you're going to have 3 complex zeros. So far, we've only got 1. Use this to get the rest. So we started with 2x cubed, so this is now 2x squared. So what I have left down here, I'll write it in black, is 2x squared, no x's, and just 8. So I can actually solve this at the same time as factoring it. And if you're in my class, regardless of what the textbook's directions say, if it says to factor completely, I also need you to solve. So make sure you do that on every problem. Factor and solve. So let's finish solving this guy. We could use the quadratic formula, but I think I'm just going to solve for x by moving that 8 to the other side, dividing by 2, and now coming in and operating with my square root. Of course, if I operate with a square root, I have a side effect of plus or minus. So this is going to be plus or minus. Since I have a negative inside my radical, or my square root, that's of course going to be an imaginary number. Which makes sense with the picture back here, because we weren't seeing or detecting any other zeros. So the fact that they're imaginary makes perfect sense. So how would you write down your answer to this problem? We've got everything we need. We would say f of x factored completely is, the first factor we found had -1/2 for the zero, so you could go x plus 1/2. There's also other fancier ways to write that. I'll just give you a clue that 2x plus 1 would be another equally good way to write that down. These are the same thing. I'll leave that to you as an exercise to figure out yourself. And the rest that we got was 2x squared plus 8. You might be expecting to have to get lines, but remember, this guy doesn't factor anymore because you have complex imaginary zeros. So that's what I'd want to see for the complete factorization. Either this or same thing right here. Either one of those would be the complete factorization of that problem. Since I want you to solve it as well, I'm also going to want to see this. You to have something, oh, that marker is dead. There we go. So I also want you to have something that says what the zeros are. So for this problem, the zeros are -1/2, just like we found. And we already reduced those. We have 2i and -2i. 1, 2, 3 zeros for third degree problem. Let's look at a couple other examples. Same kind of thing, we just want to do a couple other problems. about this one? Okay, so let's take the same approach we had before. We'll go to our calculator. Go to our graph. 5x raised to the 4th power plus 40x. Zoom 6. Here's our starting spot. So it looks to me like we might have a 0 at -2 and it came back up. Looks like there might also be a 0 at 0. I'm not sure about those. Let's just start and check them with synthetic division. So here we go. First I'm going to check the 0 of -2. Peel off my coefficients. 5 cubed is missing, squared is missing, 40 is x, 0 is the constant. Here comes the synthetic division. Bring it down, multiply, add, multiply, add, multiply, add, multiply, add. I knew that was going to happen because we had a 0. So now what I'm going to do is use the other 0. We also saw it looked like it crossed at 0. Am I sure about that? Well, maybe I am, maybe I'm not. Let's check. So now, without starting a new problem, I'm just going to take the quotient and continue dividing with it. So here we go. Here's a different color. Bring down the 5, multiply, add, multiply, add, multiply, add. Get black in there for that guy.
Rose Blanchard to the administrative office. Rose Blanchard to the administrative office.
Okay. I don't see any other zeros on here, so we might just be missing them, or they might be complex. The nice thing is that I've gone from 4th degree, right here, to 3rd degree, right here, to 2nd degree, right here. And if I've got a 2nd degree polynomial, that means it's a parabola. So I can use things I know about parabolas on it. So you know what? I'm just going to write this down and work with it separately. 5x squared minus 10x plus 20. We know a lot about parabolas. The first thing that jumps out at me about this one, I'm going to turn my calculator off, is that they share 5. So I'm going to pull that 5 out. What's left is x squared minus 2x and 4. I could try to factor this standard easy trinomial, but factors of 4 don't add up to -2, no matter which ones you choose. This doesn't factor. If it doesn't factor, remember in parabola land, you have to go to your big gun, the quadratic formula. So I'm going to finish this problem by using the quadratic formula to solve that guy. So x equals -b, so that's -2 plus or minus b squared, -2 squared is 4, minus 4, a is 1, c is 4, all over 2a is 1, so it's just 2. And now I just need to simplify this down. We'll see if our answers are imaginary, as I expected, or not. So we've got 2 plus or minus 4 minus 16 over 2. So that's 2 plus or minus the square root of -12 over 2, which is 2 plus or minus 2 roots of -3 over 2. Of course, I'm just breaking that as that. So I'm going to keep simplifying here. Negative is going to give me I was right. We're going to have imaginary numbers here. So 2, oh, you know what? Let's take that 2 out. 2 over 2 is 1. 2 over 2 here is also 1. Square root of 3 is the square root of 3. Square root of negative is I. So I think I've got all my scratch work that I need in order to write the answer down nice and neat. I'm just going to go back and get rid of my, well, not quite yet. Let's write it down right up here. We'll just use a different color, light green. So this guy factored completely is going to have several factors. -2 makes the factor x plus 2. 0 makes the factor x plus or minus 0. But since you don't really need plus or minus for 0, you can really just write x. So you'll see x like that quite often on these problems. And then the final factored version of this was we had a 5. You know what? I'm going to put that 5 way out in front here. I think these are all multiplied, so I can do that. And the other parts we had was x squared minus 2x plus 4. So we've got a line, and a parabola. You should expect this parabola to factor further, but we tried, we were not successful. In fact, we showed with the quadratic formula that you get complex answers. If that is the case, and this is as far as it's factorable, that guy is completely factored right there. The last thing I need to do is list my zeros. We've already found them. -2 was 1, 0 was 1, and when we reduced our quadratic formula, we found the last two. 1 plus the square root of 3i, and 1 minus the square root of 3i. So there's a second example. You want to consult my other videos for more examples because this is a complex concept with lots of steps. And there's always alternative methods, or at least a lot of the time there are alternative methods. Let me show you an example of how to do this problem a different way. We'll leave our answers up. We'll just erase the work that we did to get them. If I erase the work that I did to get those answers, here's another totally alternative way to do the problem. Oh, need to erase that synthetic division as well. If you just focus on this guy, what do the two terms share? They share 5 and they share x. So you could pull out a 5x and see what's left. What's left here is x cubed. What's left here is 8. There's step 1. Step 2, recognize that this is a sum of cubes. I think we've a couple times applied those special sum of cubes and difference of cubes factoring formulas. Let me write it out again for you. I'll go a little bit slow. How does the sum of cubes factor? Well, x times x squared is x cubed. A times a squared is a cubed. You have to remember there's an x and an a in the middle, and you also have to remember that plus starts as plus, minus plus. I can use this factoring formula, this factoring sum of cubes, to factor this guy and say 5x. What is being cubed here? It's 2. A, in other words, is 2. So I can write this guy as x plus 2, x squared, 2 squared, 2x plus minus plus. If you look at this and compare it to what we got when we used our calculator and synthetic division, I think you'll find that they are identical. 5x, x plus 2, and the parabola. Of course, I don't need to go and solve this because I've already used my quadratic formula to find this guy's zeros are those right there. So there's a completely different way to use a formulaic approach instead of a synthetic division approach to solve this problem. In the next videos, you'll find more examples where you use both methods. I'll see you then.